Hello, wonderful students. This is Mr. Manson, and today we're going to continue what we did last class with converting between the exponential and logarithmic form, and this is exactly what we did last time. So what we said was we had something in the form of y equals b to the x. To convert that from exponential to logarithmic form, we would write that using the numbers or variables for y equals b to the x and replace them here. And this would be read as log base b of y equals x. So for an example, if I said 2 to the 4th power is 16, that's like saying y equals b to the x, and it doesn't matter which side y is on. So 16 is the y, 2 is the b, and the 4 is the x. So we would rewrite that to be log. The base of the exponent is the base of the logarithm, so the little b goes here is 2 of y, which is 16. It will always equal the exponent, which in this case would be 4. And then what we did last class too is we went backwards. So for example, if I had, let's say log base 8 of 64 equals 2, and that's given to me in logarithmic form, and I want to go from log form to exponential, you simply start at the little base, that's your b, I raise it to the y, and then I set it, raise it to the x, that's x, and set that equal to the y. So then you would write that as 8 to the 2 equals 64, just like that. So that brings us to what we're going to look at in our next assignment, assignment number 8. What we're going to do here in this next example is we're going to convert this statement to exponential form, just like we did, and we're going to find what the missing value should be that's given here for x. So for this first example, this one says log base 2 of x equals 4. And our job is to find out what the missing value for x is. So the first thing we want to do is we want to convert from log to exponential form. So given that this is log base b of y equals x, you would do the around the world trick. Raise 2 to the 4 and set it equal to x to get 2 to the 4 equals x, just like that. Once you do that, simply find what 2 to the 4th is to get x. Once you do that, you get x equals 16, because 2 multiplied against itself 4 times is 16. Okay, so let's take a look at another example of that. Suppose in this example we have log base x of 32 equals 5. Here the x is in a different spot in the base of the logarithm, but that's okay. We still follow the same directions. Convert to exponential form, and we just find the missing value. So, starting at the x, I raise it to the 5, and I set it equal to 32. So something to the 5 will give me 32, and that's what it is in exponential form. Now our job is to figure out what would we raise to the 5th to give us 32. Now, I wouldn't give you these unless they could be done. So if you think about 32, let's do a little factor tree back in the day. If I keep halving it, double 32 is 16. 2 times 8, and if I keep splitting 8 up, that would be 4 and 2, and that 4 would be split up into 2 2s. So basically my whole point here is 32, if you look at the berries on your factor tree, remember branches can't grow off the berries. Oops. Here where we have 1, 2, 3, 4, 5 2s. So we know 32 is 2 to the 5th. So since I know 32 is 2 to the 5th, I can say that x equals 2. Because that's what the missing value would be for that. So it would be log base 2 of 32 equals 5. So you'd convert it to exponential form. X to the 5th is 32. And try to figure out what to the 5th would give you 32. If you're not sure, just make a factor tree or break down the numbers or play around with them with your calculator. Let's look at another example. Here we have, for this third example, log base 3 of 81 equals x. So for this one here, I want to convert to exponential. 3 to the x would give me 81. So I got to figure out 3 to the what would give me 81. And that may not be obvious, so let's do a little factor tree. If I break down 81, I know 81 is 2 obvious factors are 9 times 9, which those 9s can be broken down into two products of 3s. So here we have a total of 4 3s. So that tells me if I take 3 and I raise it to the 4, I get 81. So what is my answer? X equals 4. Let's look at the next one, example 4. This one says log base x of 36 equals 2. So convert that from log form to exponential form. X to the 2 equals 36. And I hope you know that what squared will give me 36? Well, this has to be the same number. Well, 6 times 6 will give me 36, so x would have to equal 6. So I can write it just like that. And then let's take a look at number 5. This one says log base 7 of 1 equals x, so I would write that as 7 to the x equals 1. So 7 to the x equals 1. And then here, how can the 7 become a 1? Well, remember, this is a special case because these numbers are so different. Remember, something to a power here will always equal 1. Well, that would be when x would be 0. Anything to the 0 except for 0 is 1. And then here's another strange case here. This is something I won't give you, but this would be a weird situation. This one says log base x of 1 equals 0. So if I convert this to exponential form, this says x to the 0 would give me 1. So what would be an answer that would be true for that? Well, I know anything would be the 0. Anything to the 0 is 1. 2 to the 0, 3 to the 0. So I can say x can be anything. Oops. Let me adjust this here, excuse me. X can be anything except 0, because you can't have 0 to the 0. But you won't see anything like that. That's what we call that a strange example. All right, well, this is in preparation for assignment 8. So let's take a look at that. For assignment 8, I just give you 10 questions. And for these 10 questions, you are to put all of these into exponential form and then find out what x is. So let's just do a couple together to make sure we're on the right path together. Here we have log base 10 of x equals 3. So I convert that to exponential form. You get 10 to the 3 equals x. So if I take 10 to the 3 equals x, well, that's 10 times 10 times 10. That's a 1 followed by 3 zeros, and that would be 1,000. So there you would get 1,000 for that. And let's do one more together. Let's say, let's take a look at number 5. Log base 5 of 125 equals x. So we have 5 to the x equals 125. So I get 5 to the x equals 125. And that may not be obvious, but if you break down $1.25, well, that would be 5 quarters, and they would be 5 nickels in a quarter. And there, the berries would be 3 5s. So here we have x equals 3. And that's what you get for that. Okay, so keep on doing the great work that you've been doing. Keep up. We only have a couple more weeks left, and I will see you soon. Take care.